All right, lesson 4.2, geometric representation of complex numbers, possibly the coolest thing that we do in all of mathematics. All right. So, real quick, what are complex numbers? Complex numbers, that's an issue. Uh, we know that it's anything in the form of a plus bi, where a and b are real, and I is the square root of -1. All right, so what that essentially says, if you think about like you have your the natural numbers, the whole numbers, the rationals, the integers, that's backwards, integers and rationals, and we have the irrational numbers, and then all of this is real, right? Everything in here is real. All the numbers you ever really knew, and and that is just inside of the bigger complex numbers. And these complex numbers are really two-dimensional numbers, right? A plus bi, where I is the square root of -1. It's almost a binomial of sort where you have two parts to this number. And I say two-dimensional on purpose because we're going to plot these on the complex plane. All right, it's coordinate plane where the horizontal axis is the real number axis. The imaginary axis is the vertical axis. And um, so, numbers a plus bi can be converted into x plus yi, right? If that makes things a little bit easier for you. So it asks us, right, to plot these in the complex plane. So -2 plus 4i, that a, -2 plus 4i would be the point right here. -3i, well, -3i would be here. 0 on the real axis, -3 in the imaginary axis, and that's your point B. 3 minus 5i, so 1, 2, 3 minus 5i. That's your third point there, and 4, right? That's 4 in the real, and no in the imaginary. This is the real number line that you have been using. That number line right there, you've been using it your whole entire life. We just ignored the imaginary axis, and you've been playing with this your whole life, but now all of a sudden numbers are two-dimensional, right? Numbers are two-dimensional, which I think is fascinating. All right. So, get to it. We're going to say that in rectangular form, uh, coordinate points are in the form of a plus bi, or z equals a plus bi. All right, z is a complex number. All right, we're going to use z as our complex number for all this. And no, it's not the z-axis in three-dimensional. It's not the same. Polar form, z is equal to r cosine theta plus r sine theta I. Whoa, what does that mean? Wait. So if we have some sort of a something or other, right? We have some coordinate point, a plus bi. That's our complex number in the form of a plus bi. And so if we want to think of this, the a value would be r cosine theta, the b value would be r sine theta, right? The x and the y distances to get to that coordinate point. But if we think about this in terms of polar, right? Think about your polar coordinates, we would face some theta, travel some distance r to that exact same point. So when they say rectangular, that's a plus bi. When we say polar, we're saying r cosine theta plus r sine theta times I. Now, there's some ways to write this a little bit more simply. What we can say is that they both have an r, so we can pull an r out, and we're left with cosine theta plus I sine theta. I know, why all of a sudden did the I go in the parentheses? It's just, I've never seen the I after sine. Just never seen it that way. But what's really nice is we wanted to, we could even, the cosine, since I have the same theta, I can shorthand this, right? So what you're going to see often is our complex number z is in the form of r c I s theta. And now that is polar. And it all means the exact same thing. Right? This is a polar coordinate point. So complex numbers, a plus bi, can be in the form of r cosine I sine theta. Cosine theta, I sine theta. And so we're going to use this polar form and this rectangular form, and we're going to convert, go back and forth between the two. Okay. So it's telling us to convert the following to rectangular form and round to the nearest hundredth. Now, how do we convert between the two forms? We know that A is equal to R cosine theta and B is equal to R sine theta. And so here we're given the 50 degrees, and it's 2. So our R value here is 2. So A is 2 times cosine of 50, and our B value is 2 times the sine of 50. And now we have to go plug that into a calculator. That should be nice and annoying. Oh, cool. I'm glad all this is up there. And you know what I've been working on all these days. That's my calculator. There you are. Okay. So let's go home. I want to calculate. What I would like to calculate here is 2 cosine of 50. I get 1.28, so round to the nearest hundredth, so 2/9. So my A value is 1.29, and now we're going to plug in 2 sine 50 into our calculator. And hit OK. To the nearest hundredth is 1.53. Our B value is 1.53. Okay. So now, from polar to rectangular, I now have my A and B. So we can say that 2 CIS 50 from polar to rectangular would be 1.29 plus 1.53i. That would be the complex number in rectangular form. Okay. 3 CIS pi. Oh, okay. I'm glad all of a sudden we are in radian. All right, so I know that my A value is equal to R cosine of pi. B value is R sine pi. So cosine of pi, what's my x value out here? My x value would be -1. So A value here is -3, or 3 times -1, right? And our B value, so sine of this is 0. So we get -3 plus 0i, or just -3. So 3 CIS pi, or cis pi, however you want to say it, I don't care. It's just the number -3. Not bad. All right, now we got to convert to polar form. All right, so converting from polar to rectangular, pretty simple with the two formulas for A and B. Now, going back, rectangular to polar is going to be a little bit different. We know that R squared is equal to A squared plus B squared. And we know that theta is equal to tangent inverse of b over a. All right, so we get the first one here. Starting with our r squared is equal to -1 squared plus -2 squared. So r squared is equal to 1 plus 4. R squared is equal to 5. So r is equal to the square root of 5. And it says round theta to the nearest degree. All right. So theta is equal to tangent inverse of b over a. So -2 over -1, or just 2 over 1. All right. Come on, calculator. What do you got for me this time? All right. So we have part 10. 2 over 1 is 63.4 degrees. It told us to round to the nearest degree. So that's going to be 63 degrees, approximately 63 degrees. All right, so now we have our r and our theta. So we can say that, where did you go? We can say that we now have -1, -2i convert to root 5 CIS 63 degrees. Right. Let's try this next guy here. We know that r squared is equal to -7 squared plus 5 squared. So r squared is equal to 49 plus 25. So it's at 74. 50 plus 25 is 75 minus 1 cent. Right. So r squared is 74. So r must equal. Let's use that calculator, huh? Hey, square root of 74. I don't know. That's going to be friendly. It is not. She's not friendly at all. So the square root of 74. We know theta is equal to tangent inverse of b over a. All right, so b over a. That means we got a 5 over -7. All right, so tangent inverse of 5 over -7. And that kicks back at -35.5, rounded, -36, is rounded to -36 degrees. Oh, man. Boy, did we make boo-boos. Let's just finish this here. This would be square root 74 CIS 36 degrees. But there's a problem, right? And there's a problem with both of these. -2, -1i in the real imaginary plane, -1, -2i, that's in the third quadrant. And 63 degrees is not in the third quadrant. So that cannot be true. We would have to, as 63 is in the first quadrant, we'd have to add 180 to it, right? So 180 plus 60 is what, 240? So 243. So this is not the right answer. That's not the right answer. The real answer is root 5 CIS 243. That's what we're looking for. Let's get a better 3 in there just so that y'all don't yell at me for that. And is 36 the right angle? Oh, no, we said it was -36. And we can't have negative. So it has to be between 0 and 360. So what quadrant is this? -7 plus 5i. -7 plus 5i. That would put us up there. And that's quadrant 2. And if -36 is here, we got to add 180. Or we do 180 minus 36. Right, so 180 minus 30 would be 150. 150 minus 6 is 144. So this is really, that's not right. You're going to say the square root of 74 CIS 144 degrees. There we go. That's the one. Gotta be careful because tangent's only going to be -90 to +90. All right, let's keep cruising. See what we got. Oh, that's it. Sweet. That's all we need.